All right. Hey, everyone, can you hear me fine? Yeah? All right. So I'll give a little bit of background about the talk and a little bit about me as well. Evil neighbor attacks, it's something we essentially came up during some of our red teams that we were doing. Essentially, we're just talking about bad neighbors on SaaS platforms, right? That's the basic premise. A little bit about me really quick. I've been in cybersecurity for about 20 years, grew up in India, moved to London about 2 years ago now. I run a consulting firm called Security Brigade, which has been around for about 18 years. And the other one's not coming through for some reason. A SaaS platform called Shadowmap as well, which does dark web monitoring, attack surface management, etc. So as part of our red teams, right, we run across a lot of really interesting scenarios. And the traditional SaaS, the SaaS and cloud has sort of changed the stack that we typically deal with, right? I've spent about 18 years doing red teams now, and traditionally red teams were always oriented towards your traditional perimeter, right? You're looking to get onto Active Directory, you're looking to get onto lateral movements once you get onto the network and sort of go from there, right? In the last couple of years, we've been doing a lot more red teams that are startup oriented, so a lot more SaaS oriented, a lot more cloud oriented, a lot more AWS. And it sort of changes things in terms of our approach and what we typically do in a red team, right? So the whole talk that I'm going to give you today is a red teamer's perspective, which is a little bit different from, of course, the DevSecOps folks are a little bit different from the pen testers. It kind of looks at a broader sort of perspective, right? Just a quick sort of example of a sample red team journey that we did a couple of years ago, actually. Just to give you a context of what cloud or SaaS red teams typically look like how they differ from your traditional perimeter-based red teams. So this one started with an HA proxy server that was running publicly, misconfigured. Let us start talking to things behind the network that weren't supposed to be public, right? Went from there to accessing an internet domain, so a private domain, to accessing a Django server that was running on debug mode. Debug mode gave us a bunch of password hashes that had weak passwords, cracked those passwords back, and they were using the same credentials for VPN, or very limited VPN, right? So this was just a gateway VPN. Essentially, you route through their IP address, but you can't really access any on the LAN, right? Turns out they had a bunch of instances running on AWS that were whitelisted to that particular office IP address. So now we had Jenkins running on a whitelisted basis. We could start accessing Jenkins and go from there, right? Jenkins had Google single sign-on. We were able to get around that because they weren't checking what domain you were coming from. You could log into your personal Gmail and still get in. Pretty classic flaw there, right? Use the Jenkins build functionality to start executing commands. So Jenkins has a really interesting functionality. Once you're admin, is essentially you can run commands locally on the Jenkins instance with a scripting interface. Ran the commands, extracted the passwords that were saved, secrets that were saved inside Jenkins, decoded them, got GitHub, I believe credentials that had 2FA though. But what's interesting is when you try to enumerate GitHub through the API, it actually doesn't ask for 2FA in most cases. As long as you know the repository names, it will let you check them out and download the code. So did that, got about 200 repositories. One of them was called DevOps, contained a bunch of SSH keys inside them. Use those SSH keys to find some jump servers, connect to those servers, get onto their SSH. They had sudo enabled, got root, bunch of saved SSH keys, hopped onto a bunch of different machines on the network, and pretty much had everything at the end of that, right? So that's typically what our cloud SaaS red team journey looks like. And it's really interesting because it's very different from what red teams traditionally used to be, right? No Active Directory, no real enterprise compromise, right? Everything sort of happened outside the network. So what I'm here talking about today is essentially evil neighbor attacks, right? I'm talking about multi-tenant SaaS platforms. So your Bitbucket, your Cloudflare, anything, right? GitHub, any of those solutions that most enterprises use, where you have a single set of infra and then, of course, multiple different organizations using it. And we've seen some interesting attack scenarios that we were able to come up with during our red teams that we could leverage and sort of use that to compromise things, right? So I'll give you a couple of examples and I'll talk more about these as well. So one is abusing certain functionality within Cloudflare to get past the WAF. So even when the origin is restricted, limited, no public access, we could still bypass the WAF and sort of hit the endpoints and get around that. Second is a Cloudflare access scenario where we're able to, I'll talk a little bit about what Cloudflare access is for anybody who doesn't know it. But we're able to get around Cloudflare access and directly talk to the end applications, essentially bypassing the zero trust authentication that they have in place. And the last was Bitbucket, where we were able to go and talk SSH to servers that weren't supposed to be on the public internet at all. So your enterprise servers that are behind your firewalls, IP whitelisted, restricted from Bitbucket, for everyone but Bitbucket, and we could still get around that and talk to them. So I'll go into more details, but that's the other thing I want to add right now is the attack idea isn't really limited to Cloudflare or Bitbucket. These were just examples that I saw during a certain set of red teams. These would work for most SaaS platforms where there's whitelisting or limitation, that some sort of controls that you're putting in on your enterprise end. And you'll see what I mean when I talk a little bit more about it. So getting through the WAF, right? So again, just a little bit of a refresher. Cloudflare WAF, essentially any cloud WAF, right, is primarily going to work by routing your DNS to Cloudflare's DNS. It's going to route all your traffic to Cloudflare's WAF, and it's then going to talk to your origin server, right? That's your standard WAF implementation. They typically recommend that you use Cloudflare tunnel or IP restriction on the origin server to make sure that an attacker can't get around it and talk directly to your origin server, right? Which typically happens. When you look at WAF bypass, there's typically two ways that it'll happen. One is you're either using some sort of input manipulation to sort of bypass the signature, and the second is you're trying to talk directly to the origin server, right? What we're doing is a completely third approach. And it's pretty interesting. It's really straightforward. So I've taken the example of securitybrigade.com, which is one of our websites, where if you try to access wp-config.php, it's going to give you, it's Cloudflare WAF is going to pick it up and block you, right? And this is a standard rule that Cloudflare WAF has. And you can use any rule essentially to test this out. So anytime you're trying to access something potentially malicious, Cloudflare is going to pick it up, block you, and take that action, right? And what we realized was that, so to do this attack, the first thing you got to do, right, is we had to buy Cloudflare Pro. So we had to pay for that. Gets a little bit of an audit trail there. So you need to buy a Cloudflare Pro account. It can be for any domain, right? So in this case, you can't really read it. It's for evildomain.in. It has nothing to do with any of the targets, right? It's a completely independent Cloudflare account that we've set up with no connection to any of the domains we're targeting, right? Once you buy Cloudflare Pro, you have something called health checks. So Cloudflare gives you the ability to start pinging the servers at a regular frequency to see if they're online, if they're working fine, if there's any sort of downtime, you can trigger the load balancer, you can trigger all of that, right? So what we've sort of realized, right, and what was really interesting, and we actually used this as part of our red teams, was you could create a health check for pretty much any website in the world. It doesn't really restrict it to your particular scope or your particular set of domains that are in your account. So ideally, it should probably restrict me to evildomain.in, which is the domain I have linked to the account. But in this case, what you can see is, you can't really read it very clearly. I'll sort of walk through it. Let me see if I can get a pointer. I've got the origin IP address, which we identified through just looking at past DNS records in this case, right? Historical DNS records. We've got the origin IP address. The origin, again, let me just flag, is IP restricted, no public internet access. You can hit it with Nmap and it's going to come back with no ports open, right? So that's not the attack vector. We've then asked Cloudflare's alert to look for the WP config file that we got blocked with previously. We've asked it to make sure that it's getting a 200 OK header response back. And we're asking it to add a host header for www.securitybrigade.com or any internal subdomain in this case, right? So you could add a LAN subdomain, you could add any subdomain that's mapped to that particular IP address, and we should be able to access it, getting around a lot of the controls there. And once you do this, you're essentially going to start seeing the response comes back and says it's healthy, which basically means it was able to hit that file and got a 200 OK response versus a 4 or 3 or 5 or 2 or anything that's limited, right? On the server end, you can look at the logs, and the logs will tell you that wp-config.php was hit, a 200 response got served, the health check ID that was used, which is the same ID as the health check I created, and the attacks are coming in from Cloudflare's IP addresses, owned by Cloudflare, which are the list of IP addresses that Cloudflare asks you to whitelist when you're implementing the WAF. So, put it really simply, we're abusing the functionality to use Cloudflare's own IP addresses to talk to the endpoint, getting around that origin bypass that's there, and getting us and bypassing the WAF in the process as well, right? So we can force Cloudflare to make those malicious requests on our behalf, and it's going to hit the endpoint, it's going to get processed and served, and we're going to get around that. So that's one attack that we've used a lot in our red teams, and it's been really interesting, right? The next one is again the same attack, but I'll cover both before I talk about mitigation and controls that Cloudflare already has available. Is Cloudflare Access, right? So we use Cloudflare Access as an organization. So all of our assets are behind Zero Trust Cloudflare Access. There's no VPN essentially being used. So for those that don't know it, right, I've just got a quick little GIF that plays with Cloudflare Access. But simply put, you're going to browse to your application. So in our case, it's lemon.securitybrigade.com. It's going to check your rules on Cloudflare. If everything's okay, it's going to give you some sort of single sign-on, right? So it's going to give you Google or whatever's been configured by the administrator. And it's going to potentially let you in based on that. So it's as simple as that, right? If I look at trying to access lemon.securitybrigade.com, which is one of our websites, it gives me the Cloudflare Access Google's SSO page. If you look at the actual burp requests, you can see that initially the request goes to Lemon, which redirects me back to shadowmap.cloudflareaccess.com, which checks whether I meet the rules to authenticate. So whether I'm coming from a particular IP set, whether I'm coming from a geography, a bunch of rules that we can define. And if all of that's okay, it then redirects me to Google and lets me do Google authentication and then come back and access the application, right? So in the same exact way, what we're able to do, and what's really interesting is we're able to again use the health check tool within Cloudflare to start talking to those applications which completely bypass Cloudflare Access for us. This is again, I'll talk about this in the mitigation phase, but this only works when you've done an IP address bypass, when they've done an IP address whitelisting, right? There is another method that Cloudflare recommends as well. I'll talk about that in a few minutes. But and what's interesting here is they have two options, right? One is expected code. What response are you expecting to the server? And the second is expected content. So what you can now do is you can actually make your requests and then enumerate the content that's actually on the page that's behind the authentication, right? So for example, in this case, I put in the word lemon, which is just the title of the website. And you can see if it's actually legitimate, it comes back with a healthy status. If it's not, it comes back with unhealthy. And you can see if you mouse over it, it says response body mismatch error. So if you're looking for sensitive files, right? If you're looking for password files, config files, something of that nature, you can actually enumerate keywords, letters. You could use a blind SQL injection method where you can actually enumerate one letter at a time, figure out the letters that are in use and then use that to go back, right? So there's a lot of interesting things that you could use this for potentially. But yeah, so I'll talk about how to fix it as well. And this particular set of bugs you can fix pretty immediately. But yeah, we've had a lot of fun with this during our red team so far, at least. Yeah. So in terms of fixing it, so Cloudflare, when you're implementing WAF or implementing access, typically recommends restricting connections to your origin server from anywhere but Cloudflare, which is what we're abusing in this case. So if you've chosen to go with that particular method, this attack will still work, right? It'll still get us to access your web server. And the other one is Cloudflare Tunnel, which is where you use Argo or Cloudflare Tunnel to essentially create a reverse tunnel where Cloudflare daemon is running on your server, talks back to the Cloudflare network and routes traffic through that way, right? So if you happen to use Cloudflare Tunnel, you should be okay. If you're using the IP origin method, then you're most likely going to be vulnerable to this. You are going to be vulnerable to this attack, right? So that's one set of sort of attacks and one sort of vectors that we've seen here. And there's a lot of opportunity within Cloudflare as well. So I think we were experimenting using Cloudflare workers and using scripting within workers to try to leverage the same attack as well, which I'm reasonably sure is possible. We just don't have the time to explore it enough. But again, not to just point, it's not a Cloudflare specific issue, right? This is the issue that you'll see at a whole bunch of different SaaS platforms. Cloudflare being the one that I use often enough that I could pick it up and sort of talk about it comfortably, right? Yeah. So that's one set. Bitbucket, again, something very similar. So what happens during a lot of our red teams, is we end up with credentials, right? We'll get access to SSH keys, we'll get access to passwords, but we won't be able to actually talk to the server eventually because the server's behind some sort of controls. And that's exactly what happened to us during one of our red teams that we were doing. And I believe through Confluence or Jira or somewhere that we'd compromised, we ended up getting SSH keys that were being used on some particular set of servers. We just could not talk to the server, right? So we had the keys, we couldn't get to the door, and it was really frustrating. Eventually, looking up DNS records, we realized that the customer was using Atlassian products. So Atlassian, when you do a domain verification, it adds a text record you can enumerate, and we use that to figure out that they were using SSH. We did have the origin IP addresses in this case. We knew the public IP addresses from DNS records, but they were completely restricted, right? So SSH is filtered. You can't connect to it, times out. IP tables is being used on the particular instance to just block all other IP addresses out, right? So that's where we were stuck, and we spent a couple of days brainstorming, trying to think about how do we go about this. And as you can imagine, it can get really frustrating, right? You're running a red team, you've got credentials, you've got access, you've compromised, you've essentially got there, right? And just when you thought you about had it, you realize that you can't really do anything further with it. So that's where we're at. And we realized eventually at some point, so we were actually using our own Bitbucket pipelines for some deployments. And we realized that Bitbucket has some SSH tools built in, right? So it has a SSH tool built in where you can plug an IP address in, add host, it's going to tell you whether it can connect to it or not. If it can, it gives you the fingerprint back, right? So great. We could now use this to essentially run across their subnet, come back with a list of IP addresses that they had whitelisted for Bitbucket, right? So we were able to enumerate a list of IP addresses that we knew are running SSH. We knew are whitelisted for Bitbucket's IP addresses and that can't be accessed from the outside, right? So that became the next step. We went and wrote a whole bunch of pipelines. No rocket science there, right? We added the SSH keys that we had compromised or the password that you've compromised. It doesn't have to be limited to SSH, could be rsync, could be any protocol that they're essentially using for deployments, right? Since it'll be an IP whitelist, you could realistically use that. So we could then go plug in the IP address, the user, the SSH keys. Of course, the attack was based on the fact that we already had the keys and we had the passwords. But it got us to a point where we could now talk to that server that was otherwise IP whitelisted. And we could then start running the pipeline and getting access to execute commands on that particular server through Bitbucket, right? So we would simply go and edit the Bitbucket pipeline each time, change the commands that we were running, get a reverse shell going or get whatever we need to go going as part of that process. And then Bitbucket pipeline would execute through its whitelisted IP addresses. It would talk to the SSH server, execute the commands, come back, give us the response or the results in the log file or a text file or the output, however we set it up. And that would work as well, right? So yes, gave us the win that we were looking for. And these are a couple of examples, right? There's a lot of other platforms that I think are potentially vulnerable. It's just we haven't had the bandwidth to go and test each one of them out and sort of figure it out, right? Mitigating this particular attack is a little bit of a challenge, right? So currently, we've spent a lot of time brainstorming, and the customer we did the red team for was not happy. We didn't have a solution. There wasn't much we could do there, but we thought about it a whole bunch, and the only way we could really recommend to them was to sort of restructure to use Docker instances versus the direct SSH push, right? So when you're using Bitbucket pipelines, you can choose to use SSH to SCP code over to the server. You could choose to use rsync to move code over to the server. In all of those, any push-based method, this attack would essentially work, right? Because it's all leveraging IP whitelisting. So what we eventually had to get them to do was to use Git on the other end to sort of check out as part of the Bitbucket pipeline. So they would essentially use either Git to do a checkout of that and download the code so that there was no direct connectivity, or they could use Docker to then push an image from here to the Docker instance and then use Docker to come back through Kubernetes and download it. There isn't an elegant solution. Cloudflare, of course, had a great solution already through Argo tunnels. For this, we haven't thought of a good solution yet. I'm not sure how Bitbucket or GitHub even would go about fixing it. Because short of giving static IP addresses to customers, they're going to have to tell folks that there'll have to be some sort of secondary certificate or check or some sort of check that they'll have to add to fix it. But I can't think of a good fix to actually go and address this particular issue right now. Any questions so far? Happy to sort of answer as we go along as well. Yeah. They could, but I'm not sure if anyone's going to agree to deploy that. Because for Cloudflare, you're inherently using the Argo tunnel as part of your network anyway. It's not a separate measure that you would have to use. In this case, it would have to be a whole separate client and implementation that would happen. Yes, I have reached out to them. They haven't come back with a concrete solution yet, but I think, yeah. Because again, it's complicated for them because you might have multiple web services and multiple applications that you want to sort of do a health check for outside of your scope. And fixing it would mean essentially breaking every single health check that's not within the scope. Not within those scopes. It would be a big breaking change for them to do. So I don't think it's as, They probably would have to, I think for now, you're probably going to see them change the IP addresses. They'll probably want to remove the not let health check use the IP addresses that are within the whitelisted pool. So that then it has to go to the public internet anyway. But again, I'm not sure, because in that case, again, you wouldn't be able to do an origin server check. So if I want to make sure that my origin servers are working correctly and I have 10 different origin servers running, I can't do that. I would still have to route my health check through Cloudflare. So Cloudflare daemon is the only really good way to fix it and still retain functionality. I am not sure, to be honest, if it's fade. Yeah. Anything else? Oh, perfect. Yeah. So, like I said, essentially the challenge isn't really limited to these folks. It will be for most enterprise SaaS solutions. So, GitHub's build feature as well, Jenkins as a service they're all gonna fall into the same bucket, right? It's not a Cloudflare specific problem, or it's not a Bitbucket specific problem. Any enterprise solution, SaaS solution where there's whitelisting required. So, from a security perspective, we're gonna have to look at a process that rather asks the question when whitelisting is required for third-party SaaS services. Because these sort of attacks, I believe, aren't really going to be mitigated easily. It'll break a lot of functionality for it to mitigate. So it's going to be an accepted risk, I think. So yeah, it's going to be interesting, but this will, So I think it's going to have to be more of a security process change, where operational teams will have to sort of ask that question when dev teams or DevSecOps teams come back and try to figure out how to get something whitelisted for a shared enterprise service. Yeah. Yeah. And that's any enterprise service that has shared IP addresses. We sat down and tried to make a list, but it was just, it would just take a huge amount of effort to go and evaluate every single one that had shared IP addresses and some sort of human control. But logically, they would all fall to the same issue. Logically, of course, Cloudflare is the only one that had an exception, which is why I sort of took that as an example. But Bitbucket, of course, doesn't have a good mitigation anyway. So yeah, takeaway from this, I mean, honestly, so this is the crux of the talk, right? I'm assuming that as folks dig into it more, more and more services will kind of get vulnerable to it. And it's pretty interesting. But the crux of this is essentially the need for red team, the need for outside insecurity, right? Typically when we deal with a lot of our customers, folks are extremely focused on to be honest, if every time I had a CISO ask me about dark web monitoring versus just looking at their perimeter, their cloud solutions and that sort of thing, right? We tend to sort of lean towards what's being talked about a lot more than the practical risk that's actually there. And I think red teams are something that add a lot of value from this perspective. Because traditional pen testing, traditional AppSec, of course, adds a lot of value, but it's typically looking from a accepted pathway, right? I have an application, I'm looking at an application, I'm trying to get there. Red teams are forced to look from creative, interesting ways to sort of get in. And that then in turn typically identifies a lot of these really weird scenarios where we're able to access things through ways that were completely not the intended purpose or the design purpose, right? And then that drives a lot of value. So we do a lot of red teams where we are able to pick this sort of stuff up. And it might just be mess ups on the customer's end, right? It's not necessarily always going to be Cloudflare or somebody else that's really messed up. But if you look at a lot of red teams that we've done, right? For example, there are just tons of issues where it's something extremely small that results in everything else getting compromised, right? I'll give you an example. So we were recently doing a red team for a large enterprise customer. They had, every single important asset was VPN, 2FA, VPN. You had to specifically raise a ticket for VPN so that you could only access that one particular endpoint inside the network that you needed access to, and they had all of that down, right? Eventually turns out that they had a remote support platform that their IT teams were using to support users, and that's the one that didn't have 2FA. We could get access to, use that to access pull a list of all the machines, access all the machines, execute software, do everything, RSM software, I think. But yeah, and start compromising all of that, right? So it's typically that outside view, outside perspective that red teams add a lot of value to, that typically gets missed out. And yeah, so that's it. Any questions? I'm happy to answer. We're a little bit early, which not too bad, yeah.
James, if you have any questions, I'll run around with the mic. But otherwise, first of all, Yash, awesome. Thank you very much. If you want to raise your hand, I'll run around with the mic. No, I think we've maybe had the questions then. Cool. Well, we have finished a bit early, so we can get some coffee or a bit of fresh air. Brilliant. Thanks again, Yash. That's great. Thank you.